The purpose of this video is to show how to deploy TLS SSL in an AAI environment that supports a connector framework. We want to secure connections between the various components of an AAI infrastructure. It does not include the reporting server, since this is a separate component entirely, and that content is covered in other courses in our catalog. We want students to understand how all the moving parts, certificates, keys, key stores, commands, directories, and passwords work together so that the system makes sense as a whole. The procedure has several steps. Note that this procedure applies to connector framework schedulers like Atomic and BMC. Other schedulers like Distributed IWS, Autosys, and Tidal do not rely on the framework, and so this content is not relevant. There are three main steps to the overall procedure. First, we have to enable TLS on the AAI host itself. This means generating a key store and key, and then activating TLS using a file called standalone.xml. With this, AAI is no longer accessible over regular HTTP via the thick client or the web UI. HTTPS must be used. The second step consists in enabling two-way TLS authentication and encryption between the AAI server and the connector. It's a multi-step process involving multiple key stores, keys and certificates, standalone XML, and the application.yaml file on the connector host. The procedure on AAI is only required once, but must be repeated for every connector communicating with AAI. During the implementation, we recommend that you follow each step and recommendations carefully and be deliberate in the execution. Any misstep can lead to connectivity problems and security failures. We do not demo each step on the command line. We only provide diagrams, commands, and prompts. If you want to see components getting physically installed, this is shown in various modules of the administration course. This is the map of the procedure. Let's imagine a situation where we have an AAI server, a single connector framework connection. We've added imaginary host names in blue. We'll use these host names throughout the entire module. First, we secure AAI to prevent unsecured incoming connections via web UIs and thick clients. We'll use a self-signed certificate, but if yours is commercially signed, the approach is essentially the same. We create a key store or certificate and the associated key. Then we update an AAI configuration file called standalone.xml. This file stores various configurations, such as references to the key store we created. We'll uncomment the key store reference and enable HTTPS. When we restart AAI, TLS is enabled for AAI, at least for clients and web UI connections. The next step involves securing connector framework connections. We'll deploy a signed certificate on the connector host. First, we generate a signing key on the AAI host, so we can sign the connector certificates. We generate the key and associated key store. Then we update standalone.xml to enable two-way authentication between the AAI server and all framework connections and make a reference to the signing key. We restart AAI. Then we generate a signed certificate for the connector framework using the key we just generated. This certificate is packaged in a jar file. We copy the jar file to the connector host and place it in a dedicated location in the file system. Next, we import the connector certificate. Specific elements are needed, such as the AAI host, the connector name, and a few more things. On the connector host, we update the configuration file application.yaml to enable SSL. We reinstall a connector on the web interface. Again, assuming no errors, the connection between the AAI server and the connector is now properly secured. We start as root on the AAI host. We create a key store using Java's key tool, a certificate and the associated key with the recommended elements, alias, algorithm, name of the key store file, the fully qualified name, and validity. We'll be prompted for the key store password twice, as it's not typed out for security reasons. In our course, new passwords are shown in red boxes. If another password is needed, we'll show it in a blue box. We're also asked to provide the CN, which should be the AAI host DNS name. The other fields are not required, although you're welcome to provide data. Finally, we enter a password for the key, and the elements are generated and packaged in a key store with a file name you indicated. We have provided both the command templates and the arguments in red, and a command sample using our environment's names. The key store should be stored under the install directory in /jboss/standalone/configuration and can be named anything you want. Next, we set the ownership of the key store to the owner of the AAI file system, in our case uppercase AAI, and the group, which is AAI as well. Again, template in blue, actual command for our environments in black. Moving forward, we'll only use the command in black font. Finally, we can test the key store. If you do not see an error, your key store is good to go. The second step in securing the AAI server is to update standalone.xml. We're still in the AAI host, but we SU to AAI. We head to the jboss/standalone/configuration directory, delete the existing standalone.xml, and recreate a new one based on the .fresh file. Next, we edit standalone.xml as user AAI. This is part 1 of 2. We vim the file. 3 blocks need to be updated. A reference to the key stored and password is needed. Search for application realm. Uncomment the server-identities opening and closing tags, and set the key store path tag to the name of the key store you created. When these passwords are required in other parts of the configuration, we'll show them in blue boxes. In the next step, we enable HTTPS. Search for HTTP-connector name. First, comment out the HTTP connector tag. Enter the less than symbol, exclamation point, and then dash at the beginning, and close out the comments at the end. Second, remove the matching comment symbols for HTTPS. This is part 2. We enable a socket binding listener for HTTPS. Search for default-server. Comment out HTTP and remove commenting for HTTPS. You can save the file. Then as root, stop the AAI server and restart it. Assuming no errors in the start procedure, your AAI server is now HTTPS enabled. We'll use an HTTPS URL with port 8443 to connect via the web UI. We can start deploying TLS for the connector. We want the connector framework to connect to the AAI server over TLS. We therefore need to be able to generate certificates on the AAI server and then import those certificates on each of the connector hosts. We work on the AAI host as roots. We have to generate a key using generateAAI-key.sh, which can be found in the connector subdirectory. We'll use it to sign the certificate that will install in the connector host. That key will be stored in a key store, and so a new key store is required as well. That key store requires a password. During execution, we're prompted for a server certificate name. This should be the AAI DNS name or IP. This generates 2 files, the signing key called AAI connector key.p12 and connector trust.p12. Both file names are hard sets. Next, we edit standalone.xml as AAI and enable two-way TLS communications. There are again 2 parts to this. This is part 1. We have to make reference to the key and trust store. We search for security-realm name and uncomment the entire security realm name block. Then we specify the key and trust store and associated passwords. This is part 2. We enable the HTTPS listener so that the AAI server can accept incoming HTTPS connections. We search for HTTP-listener and uncomment the tag. Look for verify client equals required at the end of the tag to make sure you're uncommenting the right thing. Then we look for socket-binding and uncomment the socket binding name set to HTTPS and port 4443. This is the port used by the connector to connect to AAI over HTTPS. Finally, we restart AAI. We can now generate the certificate we're going to import on the connector host. We do this as roots on the AAI host. We execute the generate connector cert.sh, which we can find in the connector subdirectory. We're prompted for several items. First, we have to specify a connector name. This is the name of the connector as it will appear in the web UI when you create a new connection. This certificate is also being stored in a key store, and so we have to provide a password, which again we enter twice so it's not revealed. Finally, we're prompted for the AAI key store password since the purpose of this step is to create two-way encryption and authentication with the AAI server. The certificate is generated and packaged in a jar file named after the connector name. We can move on to the connector host. We work as roots. We create a new directory called secure under the main install directory, which is usually something like /opt/atomic-connector. Then we make the atomic connector user the owner of secure. We then move the jar file containing the connector certificate from the AAI host to the connector host. We set ownership so that the connector user owns the jar file. The jar file is on the connector host. We position ourselves in the main connector directory as root and execute the configure-atomic-connector.sh. There are several inputs. The URI for the AAI server. It should be HTTPS, the host name, and the 4443 port, which is found in standalone.xml in the AAI host. A hostname. The hostname can be any string. It does not affect connectivity. We recommend using the connector hostname since this is added to configuration files in the database for information purposes. For security reasons, we have to enter the connector key store passwords. This is how we make sure the certificate is legitimate. We can leave other fields empty. If anything went wrong, you'll see errors. If not, you'll be notified that everything worked as expected. Next, we have to activate SSL in application.yaml. The file belongs to the connector user, and so we edit it as that user. We update the file and look for the SSL string, which we set to true. We restart the connector and check the log. There should be no errors. Finally, we recreate a connector in the Web UI version 2. All fields remain the same. Missteps won't be immediately evident, so we recommend monitoring the connector log continuously for Java errors.